Hello everybody, welcome back. We're on the third video, part C of section 1.1 arithmetic sequence. We're going to pick up where we left off. We finished off with example 4 on the previous video, so now we're going to go to example 5. And example 5 says determine the general term and the 150th term of the sequence 12 to negative 8. So it doesn't tell us it's an arithmetic sequence. I know we're in that section, so we want to double check that. So we simply just take 2, subtract 12, and we get negative 10. We take negative 8 and subtract 2, and we get negative 10. So we see that we have a common difference of D equal to negative 10. We also have the first term in the sequence, so it would be T1 is equal to 12. So we know that these are our two pieces of information that we have from the question. So the first thing we're doing is we're just looking for the general term. So the general term is given by the formula Tn is equal to T1 plus n minus 1 d. So we're going to fill in what we have. So the general term is equal to the first term, which is 12, plus n we don't know, minus 1, multiplied by, and since it's negative, even if it was positive, I like to put the bracket just so we're not confused. So that means that the n minus 1, both terms get multiplied by the negative 10. Some people like to bring this out and make it a coefficient up front. Of the n plus 1, which is fine. Just remember you need a distributive property in order to calculate that. So the next line would be 12, and I'm going to multiply that out, so it would be plus 10n minus a negative, so it's actually going to be plus 10. So the 10n would be plus a negative. So we can just say subtract. And then the negative 1 multiplied by negative 10 is positive 10. All right? And then we just add our like terms. So we get T to the n is equal to 22. That's the 10 plus 12. And subtract 10. And there's your general term. So the formula for the general term, again, this is fine here. But the simplified version is the Tn equals 22 minus 10n. Okay? The next thing it asks for is the 150th term, so t to the, we'll replace n with 150, because that means that n is 150. If you have t to the 150th term, that means the nth term is going to be 150 because you're looking for the value of the 150th term. So I'll just use my simplified formula for that, which is 22 minus 10n. For n, we replace it with 150. That would be 22. Subtract 10 times 150, which would be 1500. And finally, we subtract 22, or we take 1500, subtract it from 22, sorry, and we get negative 1478. So that means here that the 150th term in the arithmetic sequence, starting with 12 to negative 8 and so on, is negative 1478. A lot easier than writing out 150 numbers in the sequence. That's why it works. It's very beneficial. Again, it's just a linear equation as well, right? In linear line is what you're doing here. Let's look at the next example. First thing we're doing is we're going to write down what we have. So I'm going to steal this for a minute. So we know our... All right, welcome back. We're going to do the application of arithmetic sequences. Like I mentioned, we're going to look at the first one. It says a pile of blocks is arranged in rows. The number of blocks in each row forms the arithmetic sequence 8, 14, 20, and 26. So if you know what's an arithmetic sequence, you really only need two terms because it tells you. But if we don't know, which in a lot of cases, once we have a bunch of these different patterns, we're going to have to figure out what type we have, right? So we need at least 3. This one has 4. So we have 8, 14, 20, and 26. So we're increasing by 6 each time. So that's going to be what's called D, right? So what I recommend, and again, it's completely up to yourself, I like writing in my information on my left-hand side of my page. So D is equal to 6. Right, so we have our D term equal to 6. What else do we know? Well, we know the first term. The first term is going to be 8. So T1 is equal to 8. Now, if you look at the A part says one row contains 92 blocks. So let's read the question. It says number of blocks in each row forms this. So that means that the first row has 8 blocks, the second row has 14 blocks, the third row has 20 blocks, the fourth row has 26 blocks, so on. So what we're trying to figure out what row, which is n, contains 92 blocks. So the general term is given. So it's T to the n is equal to 92. We don't know n, that's what we're looking for. So we'll go grab our formula again. And our formula looks like, I'm just going to go steal it from a previous slide. Just bear with me. Here we go. All right, so we have our formula. So let's fill in what we know. Well, we know that we have 92. That's equal to the first term, which is 8, plus bracket n is what we're looking for, minus 1 multiplied by 8. All right? Oh, sorry. 6. My apologies. Now we're going to simplify. So I'll do it a little differently than we did in the previous example. This time what I'm going to do is I'll subtract the 8 off first. So again, this is just how comfortable you are with inverse operations. So because 8 by itself here, it's joined by addition, subtraction with the rest of this. So what I can do is I can subtract 8 from this. So when I subtract 8 from both sides, I end up with 84. 92 subtract 8 is 84. And then I just copy down what I didn't use. Now, instead of multiplying by 6 using the distributive property, 6 is multiplied by everything in brackets. So what I can do is I can just divide everything by 6. Everything here. But like I said, what you do on one side, you do the other side to keep a balance. So I'll divide both sides by 6 in my next step. So 84 divided by 6 would give me 14. And sorry about that. I'm just getting used to the mic. We had an interruption there, a knock on the door. So I'll continue here. So I divided 84 by 6. I divided that. So it just leaves me with n minus 1. And then I can just add the 1 to both sides. Gives me 15 equal to n. So what this means is the 15th row contains 92 blocks. The 15th row contains 92 blocks. Let's look at the next example. So the next example says how many blocks will be in the 40th row. So it gives us the n value. So n is equal to 40. So our D, like our common difference is still 6. Our first term is 8, but the nth term, or the general term being 92, we're not concerned with that. So I just rewrite the formula. And then I fill in what I have. So the nth term, Tn, we can replace the n with 40 because we're looking for the 40th term, for the value of the 40th term, right? So it's going to be T to the 40 equals the first term, which is, sorry about that, just another slight interruption. So we are looking for the how many blocks are in the 40th row. So the 40th, that's going to be our n value, so t to the 40. And then we're going to fill in what we know. We know that the first term was 8 plus an n we know now is going to be 40 for this particular part, minus 1 multiplied by our difference, which is 6. So I just recopy that line, because what we're doing is we're just simplifying now when we get to this point. All right, so we'll just take the 40 and 1 and subtract that, and we get 39 multiplied by 6, obviously. And then we take 39 and multiply it by 6. When we take 39 and we multiply it by 6, we get 234. So again, I'm just going to copy. I know that's me being a little lazy. 234, and then we add the 8 and the 234 together for a final answer of 242. So again, what does this mean? This means that there's 242 blocks in the 40th row of this arrangement. All right. Next time, next video, we'll do the second application. Thank you.